So looking at evaluating logarithms and log equations, I'm going to do this all by example. So my first question here is solve x equals log base 2 of 256. So the first thing we're going to do is we're going to take the inverse. Now remember that if it's an inverse and it's base 2, the inverse is going to be 2 to the power of whatever it was. So I now have 2 to the power of x, 2 to the power of log base 2 of 256. Now remember, 2 to the power of anything to the log base 2 is just going to be the number at the end. Okay, so we now have 2 to the x equals 256, and therefore x equals 8. And that one's one sort of, if you like, a trial and improvement. You know, if you didn't know that, you may stick in a couple of numbers and see what happens. So x equals 8 for that one. So the next one I did was a natural log one. So we're looking at base e, and it was solve log 3x minus 2 equals k for x in terms of k. So my answer is going to have k in it. I'm not being asked to find the value of k. We're quite happy that k is going to be in my answer. So the first thing I'm going to do is take exponentials of that, because it's useless to me like that. So I have e to the log of 3x minus 2 equals e to the k. Remember, e to the power of a log is just going to be that little bit there. It's just going to be the bit there. I'm not sure what you would call that, but that bit. So 3x minus 2 equals e to the k. 3x is e to the k plus 2, and finally, to get it in terms of x, make x the subject, I divide by 3, so I end up with x equaling e to the k plus 2 all over 3. So the next thing is talking about exponential equations, and again we're looking at evaluating this, finding out what does x equal. So 3 to what power equals 215? Well, there's not a lot we can do with that at the moment, but we can take logs, so we'll do that first. So I log both sides, and again it doesn't matter what base log you use as long as you're consistent. Because I've written it as log, conventionally we say log is log base 10 because we don't bother putting the 10 down here. The convenient thing is that you are actually going to have to evaluate these on your calculator at some point, so it is far better to use either natural log or log base 10. You're not going to get any extra marks for putting it in log base 2 and then at the end of it not being able to calculate it. So log base 10 I'm using here. Now we can use our log rules, bring the power down in front. So x equals log 3, sorry, x times log 3 equals log 215. Divide by log 3, log 3 is just a number, I should say. And evaluate that, put it into your calculator, and you get x equals 4.89. So I have added on the end there. It doesn't matter which log you use, as I've already mentioned, as long as you're consistent. Okay. And if you want, now is a good opportunity, take that equation and convince yourself, use the natural log. So go through the same process but using ln rather than log, and I sincerely hope you get the same answer. If not, either I've made a mistake or you've made a mistake. Okay, the next type of exponential thing you might get is one that looks a bit like this. And again, we're just going to take the logarithms of both sides. So ln 6 to the 2x plus 1 equals ln 72. Again, we can bring the whole of that power down. That's what we use those log rules for. So we end up with 2x plus 1 is log 72 divided by log 6. 2x is log 72 over log 6 minus 1. And then you can start evaluating it out, and you end up with x equals 0.693 to 3 sig fig. And again, if you want to convince yourself that it doesn't matter what what base log you use, have a go with log base 10. But in a nutshell, that's solving exponential and logarithmic equations. Please feel free to rewind and go through the video. I'm conscious of the fact that I am talking quite fast, so I hope you can hear me and it's not too gabbled.